In honor of the Hunger Games, let the games begin. That's what we're getting ready to do here. We're getting ready to take part of the game known as protein sequencing. And these are typical problems that people have to face on a daily basis working in a laboratory if they're working with protein chemistry. Here's a protein, we're going to do this to it, and we get these fragments. And we need to take these fragments now and we need to kind of work backward to figure out how this protein was structured in the beginning. So that's very often the thing that we have to do. We have to take a look at the sequencing part of the amino acids so that way we know the order of the amino acids in the protein. The problem is that these questions can become quite lengthy because there's quite a bit of information that we can pull based on the enzymes that we're using. So this example, you're going to see up at the very top that we are first going to acid hydrolysize the protein itself. And we talked about acid hydrolysis before. This was super high heat, this was very strong acid, 24 hours, and we cleave every amino acid in the protein. We send this through a protein amino acid analyzer, and we get the following information. We see alanine showing up, we see arginine, histidine show up, we see 2 lysines involved, a leucine, 2 methionines involved, a proline, 2 serines involved, threonine and valine. So there's kind of the amino acids, the starting point, I guess you could say, that we are working with. This is what's out on the table. And we've got to figure out, notice these are separated by commas. We have to figure out now how these amino acids are all hooked up together in the protein. We took this unknown protein, we destroyed it, we broke it up into the amino acids, and we shot it through the acid analyzer. We now know what type of amino acids are there. We also know how many of each are there. And notice there's 2 lysines, 2 methionines, and 2 serines. We then take the protein and we add carboxypeptidase A to it, and we get valine as a result. We take Edmonds, we do 1 round of Edmonds on it, and we get PTH leucine involved. We take cyanogen bromide, and I look at cyanogen bromide, and it gives me 3 fragments. So I've got to know what cyanogen bromide does, and I take a look at the 3 fragments, and I see one of the fragments has about 5 proteins, the other one has 2 proteins, and the other one has 6 amino acids that are there. Sorry, I should have been using amino acid that entire time. And then I take a look at trypsin, and trypsin gives me 4 fragments, 3 amino acids in one amino acid in the second one. And the 3rd fragment, I see 5 amino acids that are listed. And in the 4th fragment, I see 4 amino acids that are listed. So I need to take all of this information that it's taken me over 3.5 minutes to basically read. And I need to put all the information together and somehow give you the order of these amino acids and how they were originally in the protein before I started cleaving them all over the place. And the answer is yes. This is enough information in order to do that. So the way that I like to solve these problems is, again, the game of hangman. So I go up here to the top and I just count how many amino acids do I have to represent in this protein. So I get 1, 2, 3, 4, and 5, 6, 7, and 8, 9, 10, 11, 12, and 13. So there's 13 amino acids here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's the purpose of the acid hydrolysis. I'm now done with that. I don't really have to do anything else with it anymore. It's told me how many amino acids that I have. I can at least write them down on a sheet of paper, provide them a little spot where they need to go in the beginning, and that's all that I need to use the acid hydrolysis for. That is it. Okay, carboxypeptidase A tells me that valine is going to be cleaved. carboxypeptidase A targets the very last amino acid of the chain. So carboxypeptidase A has now told me that valine will be in the last position. So you know, up in the acid hydrolysis, we only had one valine there, right? So I can now cross that out. That one's taken care of. I don't have to worry about it anymore. In the next one, it says Edmonds reagent. Edmonds reagent is PTH leucine. Okay, so that means the very first amino acid was leucine in this amino acid chain. So Edmonds will tell me the first amino acid, and LEU goes there. So up at the very top, acid hydrolysis, I find leucine. There was only one of those, so I can cross it out. I've taken care of it. So there's carboxy A and Edmonds. Now we get to cyanogen bromide. And cyanogen bromide tells us, if you remember, cyanogen bromide will focus on the methionine, and it cleaves at the methionine location. So it looks like when it looked for methionine and it cleaved at methionine, I ended up getting 3 fragments in total. And I've got to figure out how these things are going to go. Well, one of these are going to be very easy, and one of these is valine. Look, I only had one valine in my amino acid hydrolysis, right? And here's valine. And it's letting me know that this valine and a threonine fragment came off. So that probably means that threonine was right here. So if this is the fragment that cleaved, that also means that methionine had to be at this location, because cyanogen bromide will scan through this list and it will say, uh-oh, there's methionine, and I'm going to cleave at that spot. And I would end up getting a threonine and valine fragment, and that's what we're seeing here, threonine and valine. So just by that one fragment alone, I can assign the position of 2 more amino acids, and there they are. Another one was leucine. I mean, that's a very good starting point for us, right? So here's leucine, and I find leucine in one of these fragments. And here we go. Here's leucine. So I know that this first fragment would have leucine and all of these others in it. But there's also methionine there, and that's good news because cyanogen bromide cleaves at the methionine spot. So let's add up the amino acids that are in that fragment. 1, 2, 3, 4, 5, and 6, right? So 1, 2, 3, 4, 5, and 6. At this location, I know methionine has to be there because cyanogen bromide cleaves at the methionine fragment. And here is the methionine fragment. So that means that these 4 spots are going to be available. Leucine I've taken care of. Methionine I've taken care of. That means these 4 fragments are open up to the spot of serine, alanine, arginine, and lysine. I know that those have to be sandwiched in there in some order. I don't know really what order yet, but I know that they have to go in a certain order. So at the methionine, I get a cleavage point that happens, and that's my first fragment. My other fragment, well, it's right up here. We've not really messed with it yet, right? So this methionine is the very last one in the fragment. We've taken care of that one already. Cyanogen bromide cleaves at the methionine spot. So that means these 4 spots have to be for histidine, lysine, proline, and serine. I just maybe don't really know which one goes where yet, but that's okay. I'm at least assigning spots and narrowing down my choices. So my cyanogen bromide is now done. I really can't take anything else away from cyanogen bromide. I know that these 4 amino acids have to go in this location. I also know that these 4 amino acids will probably have to go in this location. The orders of them I don't really know yet. I'm going to have to look at the bigger picture, but I can at least assign 1, 2, and 3 more of these amino acids. Finally, I come down to trypsin, and I take a look at the cleavage fragment that trypsin gives me. Trypsin cleaves on the arginine and lysine side of things. So again, I kind of do the same thing. I look for leucine first. There's only one of those. I know that that leucine fragment, well, it's here. So leucine's already taken care of. So that means that arginine and serine have to go at these two spots. So I'm now narrowing down my choices even more. Not only that, but trypsin cleaves on the right-hand side of arginine. So that means arginine has to go here. That way I can get this fragment, and leucine will be first, serine will be second, and arginine will be third. So there is the first fragment that I'm getting for trypsin. Arginine, it cleaves, therefore this fragment, that has to be the last one that's there. So these are now taken care of. So serine, I now understand where that location is at. Arginine, I now understand where that location is at. And I'll just get rid of these dotted lines so that way it doesn't confuse you. And I'll get rid of these two spots now. So now I know that these two spots will have to be open for alanine and lysine. I've got to figure out what order they're going to go in. Trypsin also cleaves arginine, right? So in fragment number 2, is there an arginine? No, not really. In fragment number 3, is there an arginine? No, nothing there. In fragment 4, is there an arginine? And the answer is no, nothing there. Okay, trypsin also cuts at lysine as well. So number 2, it looks like just lysine got cleaved. A lysine was by itself. So we're going to have to figure out where that goes. Now look, in this fragment here I get a lysine, and in this fragment here I get a lysine. So there's 2 lysines involved. I want to wait off of that a little bit longer if I can. Fragment number 3, look, this had my valine in it, right? So here's valine, that one's taken care of. Here's threonine, that one's taken care of. There's methionine, this one's taken care of. And now I get this proline and serine that come through. So I know that proline and serine will have to be one of these two spots. So proline or serine, I know, have to be here or here. I've got to figure out what order that's going to go in. And that also means that lysine and histidine have to go in one of these two spots. Okay, so let me just separate that out a little bit more. So now I've narrowed my choices down again. Well, the nice thing about fragment number 3 is that I know that proline and serine have to go at either one of these locations. But that means that this is a fragment. So if trypsin cleaves at a certain spot, well, that means it's going to cleave here. It doesn't cleave at the histidine site, it cleaves at the lysine site. So lysine has to go there. It has to, which forces histidine to go here. There's no other way for it to happen. So these two have now been fully assigned. So there's the lysine cleavage. The cleavage has happened. Now, the issue here is that trypsin will not work if proline is immediately after it. So if I put proline here, I would not have gotten a cleavage point. I need proline at this location. That way, serine can go here and we can get a true fragment. And look, I've just assigned those amino acids as well. So there's the end of the amino acid chain. These two now have been taken care of without a problem. It looks like I also have an alanine, histidine, lysine, and methionine. So look, here's histidine, that one's taken care of. There's lysine, that one's taken care of. Here's methionine, that one's taken care of. And it looks like I've got an alanine that happens there as well, which means alanine has to go here, and that also means that lysine has to go there. So just by using the final rule and looking at how these things are breaking up, I've now determined the primary protein sequence of the amino acid chain. Check it. Trypsin. Well, trypsin will go through and it will cleave at every arginine and lysine. So it's going to cleave here, it's going to cleave here, it's going to cleave here, and that's it. So the fragments that should be represented, arginine, leucine, serine, here they are, 1, 2, 3. I should get a lysine by itself, there it is. I should get methionine, serine, threonine, valine. Well, There they are, right? Proline was in there as well. And fragment number 4, alanine, methionine, histidine, and lysine. So they're all represented. There's how you solve for the primary protein sequence. We'll do another one of these examples. I know you had so much fun and so exciting.